Welcome to today's Explainer. We've got a truly fascinating subject to explore. We're going to unpack the 30-year journey of a systems specialist, a career evolution that perfectly illustrates what makes a highly adaptable, practically bulletproof IT professional. You know, in an industry that literally reinvents itself every few years, surviving and thriving for 3 decades requires a very specific type of mind. So we're going to break down how a lifetime of technological adaptation creates the absolute ultimate foundation for modern cyber defense. Okay, let's dive into this. The core premise we're examining today is actually a pretty profound one. Can experiencing the entire evolution of modern computing, all the way from floppy disks to cloud-based content management systems, create an unmatched analytical mindset for cybersecurity? Because in security, context is everything. Understanding how a system breaks almost always requires understanding exactly how it was built, not just today, but fundamentally, right from the ground up. To answer that, here's our roadmap for today. We'll be covering the early computing foundation, web era mastery, the home lab advantage, addressing modern skill gaps, and finally, defining the ultimate cyber asset.
All right, starting with part 1, the early computing foundation. We're talking from Pascal all the way to neural networks.
Let's jump back to the 1980s for a second, an era long before modern graphical interfaces. From 1986 to 1989, we have a general programming degree focusing on structured programming, Pascal, and database management. And right overlapping that, from 87 to 94, is hands-on Novell network administration and payroll IT. This meant navigating early IBM PCs and DOS command line environments. Think about that, working entirely without a mouse. Then in 1998, they entered the dial-up internet era. If you remember waiting 5 minutes for a single image to load, you know that this forced the development of some absolutely incredible research skills, using early and frankly painful search engines to manually figure things out. Now, what's really interesting about this is how these legacy technologies translate directly into high-value modern cybersecurity attributes. Managing Novell backups and physically handling data cassettes, which, by the way, were practically heavy enough to be used as dumbbells compared to a modern cloud sync, that is the absolute bedrock of data integrity and operational security. Thriving in the DOS command line, that directly breeds file system mastery and an absolute lack of fear when facing a modern Linux terminal. And programming in Foxbase with DBF files, that builds an analytical mindset for application architecture. The tools change, for sure, but the underlying logic of how systems process, store, and secure data, that doesn't. I want to pause on this number for a second. 500. That's the page count of this subject's final academic thesis. But it wasn't just theory. This 500-page project included a fully developed application programmed from scratch for their employer, which handled employee travel expenses and generated reports. Earning an excellent grade on a project of this massive scope proves a relentless dedication to problem-solving and deep analytical capacity right from the absolute start of their career. Moving right along to Section 2, Mastering the Web Era, covering 15 to 20 years of full-stack development. As the internet completely blew up, this specialist didn't just use it, they spent a solid 15 to 20 years learning how to actually build it. Over 2 decades, they mastered this core stack: PHP, HTML, and JavaScript on the front and back ends, server administration with Linux, Apache, and Nginx, database management with MySQL, and content management via WordPress, the whole shebang. This isn't just a list of languages. This represents a comprehensive, robust understanding of how the internet actually functions under the hood. When you spend 20 years building web applications, you understand exactly where the weak points are because you've had to patch them, optimize them, and secure them yourself. Let's break down the end-to-end process they utilized. Delivering websites wasn't just writing code. It meant Step 1, purchasing domains and configuring DNS records. Step 2, provisioning the server and setting up server-side email. Step 3, integrating MySQL databases with the CMS. And Step 4, delivering the final product. This A to Z workflow is incredibly critical for cybersecurity. You really can't effectively defend against the DNS spoofing attack, or a SQL injection, or a server misconfiguration if you don't inherently understand how those components are integrated in the first place. Which brings us to Section 3, the Home Lab Advantage, continuous, self-taught networking. Moving from professional experience to personal drive, curiosity becomes a huge defining trait here. A perfect example of this is their use of virtual machines. For anyone newer to the concept, a VM is essentially a computer running entirely in software inside another physical computer.
This specialist used VMs to install Ubuntu Linux on their everyday Windows PC. Why? To safely and continuously self-teach Linux command line tools, understand diverse file systems, and practice system administration without risking their main hardware. It is pure, proactive skill building.
And the practical application extends to their physical environment too. Since 2005, so for nearly 2 decades, they've actively managed a multi-PC local home network, setting up routers, troubleshooting LAN communication, managing IP addresses, and DHCP. This hands-on, daily practical networking experience is invaluable. It means networking concepts aren't just textbook theories, they're a lived lifestyle of tinkering. When connectivity drops, they don't call support. They pop open a terminal and find the packet loss themselves.
Okay, part 4, addressing modern skill gaps. I like to call this the yes but translation.
Let's look at this objectively. Yes, the candidate has no formal experience sitting inside a security operations center, or SOC. But look at the counterweight here. They have literally decades of logical IT troubleshooting, operational security practices starting from the tape backup era, and a history of ensuring system reliability for complex networks. So the crucial point is, a SOC environment workflow can be taught to someone in a few weeks, but the deeply ingrained intuition of how systems fail and how to secure them logically, that takes decades to build. Here's another one. Yes, they have no specific Python programming experience, which we know is heavily used in modern security automation. But they have 15 to 20 years of programming in PHP, Pascal, and JavaScript. Between you and me, Python syntax is really just a new dictionary. The underlying programmatic logic required to build automation tasks has already been honed for a lifetime. With their developer background, adapting to Python is a minor hurdle, not a roadblock.
What's absolutely crucial here is the self-awareness. They specifically note the need to expand their basic AI knowledge to understand its role in threat detection. They know they need to strengthen specific networking fundamentals like modern firewalls and virtual LANs, and they recognize the need to practice modern automation. This is the hallmark of a true mature professional. They know exactly what they don't know, and they know exactly how to go learn it.
And finally, Section 5, the ultimate cyber asset, built for cybersecurity. When you step back and look at this entire 30-year journey, from the command lines of the 1980s to the full-stack web servers of the modern era, you aren't just looking at an IT resume. You're looking at someone custom-built for cybersecurity. Take this direct quote. "I am a fast learner and self-motivated by curiosity. In the fast-paced, ever-shifting landscape of cyber threats, curiosity is basically your greatest weapon. It's the driving force that compelled this individual to build applications from scratch, to spin up virtual machines just to learn Linux, and to master the entire web delivery pipeline."
To summarize what makes them the ultimate asset, just look at these core pillars. They're an analytical problem solver proven by a 500-page technical thesis and decades of coding. They're a clear technical communicator. They're a logical troubleshooter who's navigated everything from Novell to NGEX. And they possess a deep foundational knowledge spanning 3 whole decades of technological evolution. They don't just know how to use security tools, they understand the actual DNA of the systems those tools are protecting.
Which leaves us with this final thought, especially for any SOC directors or hiring managers tuning in. When you're building a team to defend your infrastructure against complex, multi-layered threats, are you looking for someone who just read a textbook and learned security last year? Or are you looking for someone who has quite literally lived, built, and adapted alongside the entire evolution of the modern digital landscape? I think the answer is pretty clear. Thanks for joining me on this explainer. Keep learning and stay curious.